All right, guys, a very good question. Very interesting question. A particle moves along a straight line so that its distance s centimeters from the starting point O is given by the relationship. So, solution, we know that the distance is given by the relationship t cube minus 15 t squared plus 63 t minus 40. This is what we have. All right. Now, the A part of the question says we should find the distances from O when the particle is momentarily at rest. Now, we need to understand this statement, momentarily at rest. At rest, at rest, very important. Now, at rest means the velocity is zero. Okay, at rest means v is equals to 0. So we need to get the velocity. Now, velocity is actually the differential of distance with time. All right, so let's differentiate s. Now, differential ds by dt from the relationship given to us will be 3t squared minus 15 into 2t, I'm differentiating, plus 63, okay, on a dot. Now, differential of a constant term is 0, so we have it this way. So we are going to have the s by dt is actually equals to 3t squared minus 30 t, then plus 63. All right. Remember, we said at rest v is 0, so ds by dt is 0. Hence, we are going to have 3t squared minus 30t plus 63 is equals to 0 because it's momentarily at rest. Now we can see we have a quadratic equation here, but we can actually simplify by dividing through by 3. So that we're going to have t squared minus 10t, then plus 21 is equals to 0. Now, solving by factorization, we'll look for two numbers when multiply gives us 21. When we add, gives us minus 10. So I think the two numbers, we have t squared is going to be minus 7t minus 3t, then plus 21 is equals to 0. I'm factorizing now. So we have t, okay, picking the first two, t into t minus 7, then minus 3 into t minus 7 is equals to 0. So we have t minus 3 and t minus 7 is equals to 0. So therefore, the times at which velocity is equals to 0 will be t is equals to 3 and t is equals to 7. Those are the times that the velocity is 0. So we need to find the distances, all right, at which the velocity is 0, that is, it is momentarily at rest. Hence, we are going to have this. At t is equals to 3, remember we know our s is equals to t cube, all right. Hope I'm not going to forget this. T cube minus 15t squared. So therefore, distance at this time will be 3 all raised to power 3 minus 15 into 3 all squared plus 63 into 3, then minus 40. Now, using our calculators, this is what we are going to have. Here is going to be 27. Then we have minus 15 into 9, then plus 63 into 3, minus 40. Okay, since we have this, then our s is going to be equals to 41. Then we have 41 meters. So we are okay with that. Then let's go to the next one. At t is equals to 7, we are going to have the same substitution. So s is going to be 7 all cube minus 15 into 7 all squared, then plus 63 into 7, then minus 40, which using our calculators we are going to have everything is equals to 9. So we have 9 meters. So these are the two distances that we have been asked to find, and we actually found it. Then let's go to the next question. The next question says, the velocity when the acceleration is 0. Okay, this is what you are going to do. When the acceleration is 0, that is the B part of the question, acceleration is 0. It means dv by dt is equals to 0. That is the meaning. All right. Because when you differentiate velocity with respect to time, you get acceleration. And we have our velocity already. Good, which is the s by dt. And the s by dt, we have it as 3t squared minus 30t plus 63. So we'll differentiate it now. So therefore, dv by dt will be the differential of this, which is going to give us 6t minus 30. All right, differential of 63 is 0. All right, now at the point that acceleration is 0, that is dv by dt is 0, we are going to have 6t minus 30 is equals to 0. So therefore 6t is going to give us 30. So t is equals to 5. Okay, 5 seconds. Now what this means is this: the acceleration is only 0 at t is equals to 5. Now we can actually find the velocity at that point. Remember, we said velocity is equals to 3t squared minus 30t, then plus 63. So at t is equals to 5, we are going to have our velocity is equals to 3 into 5 squared minus 30 into 5, then plus 63, which v will be 3 times 1 times 25. All right, good, 25. Then minus, we have 150, then plus 63, which v is actually 75 minus 150 and plus 63. So the velocity will be equals to minus 12 meters per second. So we've actually ended the question, which we've been given to answer. Now it's actually a very interesting question. You have to just take note of the fact that we have some conditions, and make sure you make use of the conditions to actually work out the question. Watch the video over and over, and please subscribe for more videos and continue to learn. Mathematics is interesting.